Computers, check. Scientific instruments, check. Slime molds, check. Wait, what? Welcome to the Unconventional Computing Laboratory, where science fiction meets scientific reality in the most unexpected of ways. Nestled amidst the humdrum of typical laboratory equipment, our researchers have unleashed their inner mad scientists to create a spectacle that would make even Dr. Frankenstein raise an intrigued eyebrow. At first glance, you might mistake our lab for your run-of-the-mill workspace. But hold on to your lab coats, folks, because things are about to get weird. Picture this. Amidst the orderly chaos of cluttered desks, you'll find plastic containers adorned with electrodes protruding from a foam-like substance. Yes, it looks like something out of a DIY sci-fi movie set, but fear not, it's just another day at the office for us. And if that doesn't tickle your fancy, feast your eyes upon our pièce de résistance. A motherboard so massive, it could make your gaming rig blush, adorned not with flashy LEDs, but with tiny oyster mushrooms. Because who said technology can't be organic, right? But before you start thinking we're trying to recreate scenes from The Last of Us, let's set the record straight. Our esteemed researchers have been at this game since 2001, fueled by the audacious belief that the computers of tomorrow will be more than just bits and bytes. We're talking about a brave new world where chemical and living systems dance hand in hand with hardware and software. Join us on a journey through the weird and wonderful world of biocomputing at the Unconventional Computing Laboratory. Like and subscribe now for more mind-bending insights, fungal adventures, and cutting-edge research and engineering that's pushing the boundaries of mega projects in science. I post 3 new videos every week, so don't miss out. Hit those like and subscribe buttons now. In simple terms, the researchers at the Unconventional Computing Laboratory are essentially asking the question, can mushrooms do math? Well, not exactly, but they are exploring the fascinating possibility of harnessing the power of fungi to carry out computing and sensing functions. Imagine this. The humble mushroom, typically known as just the tip of the fungal iceberg, could potentially become the brain of a computer. How? Well, it's all about the mycelium, the intricate network of branching roots that lurk beneath the soil. In this unconventional approach, mycelium acts not only as the wiring, but also as the electronic components of a computer. That's right. Forget silicon chips. We're talking fungal circuitry here. Andrew Adametsky, the mastermind behind these mushroom musings, explains the process with infectious enthusiasm. He mixes mycelium cultures with hemp or wood shavings, creating a cozy environment for fungal growth inside closed plastic boxes. As the mycelium colonizes the substrate, everything takes on a pristine white hue, like a scene out of a sci-fi movie. But the magic happens when electrodes are introduced, recording the electrical activity of the mycelium as it reacts to stimulation. It's like watching nature's own version of a light show, except this one might just revolutionize computing as we know it. And here's the kicker. This isn't your run-of-the-mill computer science lab. Oh no, this is the UK's one and only wet lab in a computer science department. Wet lab, you ask? That's where things get a little messy, and in the best possible way. Think bubbling beakers, swirling liquids, and the occasional waft of something vaguely organic. It's science, but not as you know it. In today's digital age, classical computers view problems through a binary lens, interpreting everything in terms of ones and zeros. While this approach has served us well, it's not always the best fit for the complexities of the real world. That's where the maverick minds of research come into play, tirelessly exploring new frontiers in technology to break free from the binary shackles. Enter quantum computers, the rock stars of the computing world, promising to shake up the status quo by harnessing the mind-bending properties of quantum mechanics. With their ability to juggle multiple states simultaneously, quantum computers hold the key to unlocking a whole new realm of possibilities, particularly in simulating the behavior of molecules with unprecedented accuracy. But that's not all, folks. We're about to dive into the world of living brain cell-based chips. Yes, you heard that right. We're talking about chips that mimic the intricate neural networks of our own gray matter. By emulating the brain's complex, multidimensional functions, these chips offer a tantalizing glimpse into a future where computing power meets the unparalleled processing capabilities of the human brain. And here's where things get really wild. Did you know that mushrooms, those unassuming fungi of the forest floor, are actually wired into a natural internet of sorts. That's right, scientists have dubbed it the Wood Wide Web. Through this biological network, mushrooms communicate with their environment and the organisms around them, sharing vital information and resources like a digital grapevine. By cracking the code of this fungal communication system, scientists hope to not only gain invaluable insights into the hidden workings of underground ecosystems, but also tap into this natural network to enhance our own information systems. It's a thrilling prospect that could revolutionize the way we understand and interact with the world around us. Ah, the fascinating world of mushroom computers, where speed takes a backseat to resilience, adaptability, and eco-friendliness. While these fungal marvels may not zoom along at the blistering pace of today's modern machines, they boast a host of other perks that make them worthy contenders in the computing arena. Picture this: a computer that can shrug off errors like they're nothing, thanks to its innate ability to self-regenerate. That's right, mushroom computers are the epitome of fault tolerance, bouncing back from glitches with the nonchalant ease. But wait, there's more. These fungal wonders are not content to simply stick to the script. They prefer to mix things up a bit. With their natural penchant for growth and evolution, mushroom computers are the ultimate shapeshifters, effortlessly reconfiguring themselves to tackle whatever challenges come their way. And let's not forget about their eco-friendly credentials. While traditional computers guzzle energy like there's no tomorrow, mushroom computers sip it like a fine wine. It's a win-win for both your electricity bill and Mother Nature herself. Now, before Andrew Adamatsky became the mushroom maestro we know him as today, he dabbled in the wild world of slime mold computers. Yes, you heard that right. Slime mold computers. Picture a creature that's part amoeba, part puzzle-solving genius, spreading its mass amorphously across space like a cosmic conundrum in motion. These slime molds may not have a degree in computer science, but don't let that fool you. They're smarter than your average microorganism. With their uncanny ability to navigate mazes and solve complex problems sans instructions, they're the Einsteins of the microbial world. But here's where things get really mind-bending. Despite their independent streak, slime molds can be tamed and controlled through various stimuli, morphing into logic gate simulators faster than you can say, biocomputing revolution. So whether you're Team Mushroom or Team Slime Mold, one thing's for sure: the future of computing is looking stranger and more surreal than ever before. Strap in, folks, because we're about to embark on a wild ride through the weird and wonderful world of biocomputing. In the realm of biocomputing, slime molds have proven themselves to be more than just slimy blobs. They're bona fide problem-solving prodigies. Andrew Adamatsky, the brains behind the slime mold saga, led groundbreaking research on what are known as Steiner tree or spanning tree problems, crucial puzzles in network design that are akin to the Rubik's Cube of the digital world. By tapping into the slime mold's innate ability to navigate complex terrain, Adamatsky and his team cracked the code on pathfinding optimization algorithms, revolutionizing our understanding of bio-inspired computing. But when Adamatsky decided to bid farewell to his slime mold comrades and venture into uncharted fungal territory, he stumbled upon a discovery that would send shockwaves through the scientific community. Enter the mushroom nature's very own brainiacs, with a surprising secret up their mycelial sleeves. We found actually the mushrooms produce action potential like spikes, the same spikes as neurons produce, Adamatsky reveals with a twinkle in his eye. We're the first lab to report about spiking activity of fungi measured by microelectrodes, and the first to develop fungal computing and fungal electronics. In the intricate dance of the brain, neurons communicate through spiking activities and patterns, a phenomenon that has inspired the creation of artificial neural networks. And guess what? Mycelium, the branching web-like structure of fungi, follows suit. By harnessing the presence or absence of these spikes, researchers can code complex logical functions, much like the ones and zeros of traditional computing. But here's where it gets truly mind-bending. Stimulating mycelium at different points enhances conductivity between them, allowing for faster and more reliable communication, just like brain cells forming habits. With mycelium boasting an array of geometries, each capable of computing different logical functions, the possibilities are as vast as the fungal forest itself. If you send electrons, they will spike, Adamatsky declares. It's possible to implement neuromorphic circuits. We can say I'm planning to make a brain from mushrooms. The fungal cast of characters in this biocomputing saga is nothing short of a mycologist's dream. From the elegant oyster fungi to the mysterious ghost fungi, and from the sturdy bracket fungi to the delicate enoki and split gill fungi, not to mention the intriguing caterpillar fungi. It's a veritable fungi fiesta in the Unconventional Computing Laboratory. So hold on to your lab goggles because this is just the beginning. According to Adamatsky, these fungal forays are merely dipping our toes into the murky waters of fungal computing. Right now, it's all about laying the groundwork, showing the world that yes, indeed, it is possible to wrangle mycelium into performing feats of computation and crafting basic logical and electronic circuits. But what lies on the horizon? Well, if Adamatsky's dreams are anything to go by, we're in for a wild ride. Picture this: advanced mycelium computers that make today's machines look like child's play, controlling devices with the finesse of a master puppeteer pulling the strings. So, while we're currently in the land of feasibility studies and proof-of-concept experiments, the future holds untold possibilities. Who knows? Maybe one day, your smartphone will be powered by the humble mushroom, and your laptop will be nothing more than a glorified fungus farm. Stranger things have happened in the world of science after all. If you made it this far in the video, remember to hit like and subscribe now, and turn on notifications so you'll be the first to know when my next video is released. I'll see you in the next video.